Hi everyone, in this video we will learn about applications and properties of nanomaterials. Nanomaterials are chemical substances that are manufactured and used at very small scale. There are several important applications of nanomaterials such as batteries, sensors, magnets, etc. During the upcoming few minutes, we will try to elaborate some properties of applications of nanomaterials. Before starting, did you guys know that a human hair is 80,000 nanometer in diameter?
Today I'll be discussing about the applications of nanotechnology, and specifically with medicine and space. So first off, we'll be discussing about the application of nanotechnology with respect to medicine. So as you can see from the graph, the nanomaterials in devices can be both used as analytical and imaging tools, or as therapeutics and drug delivery system, which can be used in the clinical applications When broadly classified, we can majorly use nanomedicine, which is actually just a name taken from nanotechnology, and the medicine can be used as a regenerative medicine, nanorobotic microbeavers, surgical nanobots, and nanogenerators. I'll explain each of them in the next slides. So the first thing we'll be looking at is regenerative medicine. So basically, regenerative medicine is to develop methods to grow, repair, or replace damaged cells and organs and tissues. So actually the main advantage of nanotechnology with regenerative medicine is in tissue engineering. So as you can see from the picture, the porous scaffold can be used as an extra tissue to be added on the human body. It can be in vitro regenerating or in vivo implantation of the human body. And the next usage is nanorobotics microbeavers. So basically, microbeavers is just an artificial mechanical phagocytes whose function is to destroy microbiological pathogens found in the human being. So these nanorobots can be used to destroy the pathogens in our body.
I classified the small portions of applications into three subtopics. First one, high power magnets. Second, high energy density batteries. And final one, purpose of high definition TV. Let's see briefly about these three subtopics. First subtopic, high power magnets. A magnet's strength is measured in the terms of saturation, magnetization, and coercivity values. These values will increase when there is a decrease in grain size and an increase in the specific surface area of the grains. Common applications for these high-power rare earth magnets include ultra-sensitive analytical instruments, quitter submarines, land-based power generators, automobile alternators, motors for chips, and magnetic resonance imaging (MRI) in medical diagnostics. And the pictures were shown here is automobile alternatives and quitter submarines. Let's move to second one, high-energy density batteries. Traditional and rechargeable batteries are used in nearly all applications that necessitate electric power. Nanocrystalline materials produced using sol-gel methods have a foam-like aerogel structure that can store significantly more energy than their traditional equivalents. Hence, they are highly suitable for separator plates in batteries. Moreover, nickel metal hydride batteries made of nanocrystalline nickel and metal hydrides have been predicted to necessitate much lesser recharging and to last considerably longer because of their large grain boundary area and improved chemical, physical, and mechanical properties. These applications include laptop computers, automobiles, toys, electric vehicles, personal stereos, cordless phones, cellular phones, watches, etc.
Properties of nanomaterials.
Now, coming to chemical properties. Chemical properties of a surface are determined by its structural formula or molecular formula, composition of nanomaterials including degree of purity, known impurities or additives, its phase identity, or its hydrophility. Properties of a surface are determined by its structural formula or molecular formula, composition of nanomaterials including degree of purity, known impurities or additives, its phase identity, or its hydrophility. Physical properties. Physical properties of a surface are determined by size, its shape, its specific surface area, aspect ratio, its size distribution, solubility, surface structure, including crystallinity and defect structure.
Magnetic properties of nanomaterials are different from that of bulk material. This is due to the large surface area to volume ratio, which results in a large proportion of atoms having different magnetic coupling with neighboring atoms, leading to different magnetic properties. Let's look at this with an example. Bulk, gold, and platinum are non-magnetic, but of the nano size, they act as magnetic particles. So let's see what are electrical properties. When the bulk material is reduced to nanomaterial, the electrical conductivity decreases. This is due to the increased influence of the wave-like property of the electrons and thus increased surface scattering. However, the electrical conductivity can be increased due to better ordering in microstructure. Let's see this with an example. Nanotubes, which are long thin cylinders of carbon, because of the symmetry and unique electronical structure of graphene in the nanotube, it has a very high current carrying capacity. Their electrical properties change with diameter, their twist, and number of walls. So to explain about the optical properties, since the nanoparticles are so small, the electrons are not free to move about as in bulk material. This movement is restricted and the particles react differently with light. Bulk gold appears yellow in color, nano-size gold appears red in color.
The purpose of this video was to identify and realize the properties of nanomaterials so as to apply in it the usage of batteries, magnets and phosphors of HETVs. We conclude that nanomaterials are very attractive and useful properties which can be used for a range of purposes, some of which were described in the video. Thank you.